Hello everyone, my name is Radu Horoiu. I'm a professional services engineer at Infinet Wireless. Thank you very much for joining our webinar. Today I will show you the main features of the new Point-to-Multipoint module of the InfiPLANNER tool of Infinet Wireless. The agenda includes 3 items. I will begin with an overview of InfiPLANNER, pointing out its main characteristics. Then I will show you the main features of the new Point-to-Multipoint module. And in the end, I will summarize the main benefits of using InfiPLANNER. As you probably know, InfiPLANNER is the radio network planning tool of Infinet Wireless, which enables you to design point-to-point and point-to-multipoint links and carry out quick estimations for throughput, distance, and availability. InfiPLANNER has been available for over a year, but until recently it only offered support for point-to-point connections. Last year we made a screencast about InfiPLANNER point-to-point, so if you are not familiar with the tool, please watch the video on our YouTube channel. The first and most important characteristic of InfiPLANNER is that it is very user-friendly. It has been designed in such a way that it can be used by anyone who has at least a bit of basic knowledge about the wireless radio technology. Then, the InfiPLANNER tool is cloud-based, so you don't have to install anything on your PC. InfiPLANNER has been entirely developed by Infinet Wireless in-house as part of our ongoing efforts to improve our core products as well as the auxiliary tools. The key parameters like throughput, availability, and distance are computed for each unit at every available modulation. To predict the signal propagation, InfiPLANNER uses a combination of ITUR P.530, ITUR P.838, and the Longley-Rice model, taking climate zone conditions into account. And the last characteristic I want to point out is that InfiPLANNER allows you to export KMZ files so that you can also open your projects using Google Earth. To access the Point-to-Multipoint module, you must go to infiplanner.infinetwireless.com, same as before. Then log in using your credentials. After the login, the website will ask for your permission to get your location. If you click Allow, the map will be centered according to your geographical position. If you click Block, the map will remain at the default location and you will have to scroll across it to go to the location where you want to position your equipment. So, to use the new Point-to-Multipoint module, press the PTMP button in the top left corner of the window. Because I anticipate you will ask me this, I'm going to tell you from the start that the two modules work separately. So, at least for now, you cannot have both point-to-point and point-to-multipoint links in the same project. In the top section of the web page, you can expand the Project Settings panel, where you can create a new project, delete old projects, edit the name of the current project, change the distance measurement system, and you can also export or import KMZ files. I will show you more about the KMZ export a bit later. Right now I will create a new project and I will name it PTMP Demo. Now to start adding devices, you can click anywhere on the map and then select Add Subscriber or Add Base Station. I will first add a base station. Now if you click on the newly added site, 5 option icons will appear around it. From left to right, the first icon called CPE allows you to transform the base station into a CPE. The second icon opens the settings menu. The third icon adds a new sector to the base station. The fourth icon allows you to move the base station across the map using click and drag. And the last icon is the delete button, which removes the site from the project. Be careful when removing items because you cannot undo the delete, it will be permanent. Now if I click on the settings icon, the configuration menu will appear on the right side of the window. Here you can change the name of the base station, or you can change the coordinates of the site if you want. Further down, you can find a list of the base station sectors. Right now I don't have any sectors, but I can add one by clicking on Add Sector or on the white plus button. You can add up to 6 sectors to each base station site. I must mention that in Infinet Wireless networks, each sector represents an independent unit or an independent base station, unlike WiMAX networks, for example, where a single base station can have multiple sectors. I know that this labeling can be a bit confusing, so please remember that here every sector is actually a separate Infinet Wireless base station. So I will click on the newly added sector to open its configuration menu. In the sector configuration menu, first you must select the frequency range. In this example, I want to use 5 GHz equipment, thus I will select 4.9 to 6 GHz. Then I will scroll down and select the device model. I will use QMXB, our newest base station, which operates using the beamforming technology. After selecting the device model, you can change the center frequency, channel width, and TX power limit. I will leave these parameters to the default values. Further down, we have the antenna height, which I will set to 20 meters. And we also have 2 new settings which weren't present in the point-to-point module: azimuth and tilt, or elevation. You can adjust these 2 parameters either from these 2 bars in the menu or by using the 2 graphical tools from the terrain profile bar. These tools also help you get a better idea about the spatial orientation of the sector, especially in the vertical plane. Of course, you can also input the azimuth and elevation values directly in the corresponding fields that you can find on both the terrain profile bar and the sector configuration menu. The azimuth can be set anywhere between 0 and 360 degrees, while the tilt can be adjusted between -60 and +60 degrees, which should cover all practical situations. There is also a third way of adjusting the azimuth. You can position the cursor above the dashed line across the center of the sector beam, and then click and drag to change the orientation of the beam. I will set both the azimuth and tilt parameters at 0 degrees for this sector. To add a CPE, you can click anywhere on the map, like I showed you earlier, and choose Add Subscriber. If you want to place the CPE inside the base station sector, you must right-click somewhere inside the sector area. Then click on the subscriber to bring up the 5 option icons. Mostly their functionality is the same as for the base station. So from left to right, the first icon allows you to switch from a CPE to a base station. The second icon opens the configuration menu. The third icon is used for establishing a link with the base station. The fourth is used to move the unit across the map. And the fifth icon is the delete button. The first thing you need to do after adding the subscriber unit is to link it to a base station. So I will click on the link button and then click on the base station or anywhere inside the sector represented by the green area. From now on, there will be a solid line between the CPE and the base station, indicating that there is a link between them. Next, if you click on the settings icon, you will open the configuration panel for the CPE. Here you can change the name of the subscriber unit to CPE1, for example. You can change the coordinates of the site if you want. Further down, you can choose the device model. I will select the SMN with 23 dBi integrated antenna. And you can also adjust the antenna height. I will set it to 20 meters for this example. Basically, these are all the configurations that you can make for a CPE. All the other parameters like frequency range, center frequency, channel width, and output power limit are automatically picked up from the base station. There is no limit to how many units you can add in a project, so you can continue adding as many CPEs as you need. I will add a second CPE somewhere farther away from the base station. I will make the link. Then I will go to the settings panel, rename it as CPE2, and select the SMN with 28 dBi integrated antenna as device model. If the line between the CPE and the base station is yellow or red like in this case, it means that the Fresnel zone is obstructed and some measures need to be taken, otherwise the link will have very low performance or it won't be operational at all. For a better view of the transmission path, activate the Terrain Profile tool by clicking on the Show Terrain Profile bar at the bottom of the web page. The tool allows you to adjust the height of the antennas at both ends of the link so that you can have a clear path between the base station and the CPE. Please note that the azimuth and elevation adjustment tools will always be available besides the terrain profile. Although the base station antenna pattern might be larger than the green sector area, and you could establish a link with a CPE located somewhere near the outer edge of the sector, we recommend placing the CPEs inside or in front of the green area to get a reliable connection. So I will add a third CPE somewhere outside the green sector area, but still close to it. I will link this CPE to the base station, rename it as CPE3, and then select the device model, an SMN unit with 23 dBi integrated antenna. Then if I hit the results button in the upper right corner, I can see that the calculations are made, so the link is operational. The explanation, as I have mentioned, is that the green area only shows the theoretical 90 degrees of the sector. The antenna pattern, however, is larger. Therefore, I was able to link the CPE to the sector. If I move the CPE farther away from the sector edge, the link will not be operational. And you can check this by opening the results window again. So please remember that we recommend placing the CPEs only within the radius indicated by the antenna specification, 90 degrees in this particular case. As I have mentioned in the beginning, the maximum number of sectors you can add to a base station site is 6, because you also have the option to use external antennas with less than 90 degrees coverage. So I will add a second sector by clicking the Add Sector icon. Then I will right-click on the new sector area and choose Options. This will open the sector configuration menu. I will use the same frequency range, 4.9 to 6 GHz. Now you can see that, as I mentioned earlier, I must assign a separate base station unit for the second sector, so a new sector means an entirely new base station unit. So from the device model list, this time I will choose an OMXB unit which doesn't have an integrated antenna. And then I will be able to select an external antenna from the list below. As you can see, the narrowest beam width is 60 degrees, so to cover the whole 360 degrees with this kind of antennas, you will need 6 sectors. I will choose a 60-degree antenna for this sector. You can also change the default RF cable and choose one with attenuation between 1 and 4 dB. Further down, I will set the azimuth of this sector to 90 degrees. The green sector indicators help you cover a large area with several base stations without having too many overlaps. There is no indication of actual parameter values like signal level, but the sector beams help you visualize the areas for which the base stations provide good coverage. To show you how this works, I will add a second base station site with a single sector. Having similar specification to the first sector of the first base station. Frequency range 4.9 to 6 GHz. Device model QMXB, and I will set the frequency to 5.650 GHz. to avoid interference. Next, I will rotate the sector beam towards sector 2 of base station 1. And then I will move base station 2 towards base station 1. You can see how the colored sector beam helps you design your network in such a way that you have good coverage, but you also can minimize the sector overlap. To get the availability and throughput estimations for each link, click on the Results button. From the drop-down list in the upper left corner, you can select the sector and CPE for which you want to display the results. I will first select sector 1 of base station 1 and CPE 1. The estimation report is similar to the one in the point-to-point module, and it shows two opposite modes of operation. The first mode, called maximum availability, offers the advantage of a robust and reliable link with very short outage durations at the cost of having the lowest throughput. The second mode, called maximum throughput, allows you to use the highest modulation to achieve the highest possible throughput values at the expense of link reliability, so the network downtime will be a bit higher. Please note that the maximum bidirectional throughput values may be different in the two directions, from base station to CPE and vice versa, because the parameter shows the maximum capacity that each unit can achieve. So it is not a measure of link capacity, it is a measure of unit capacity. For more detailed information, please check the detailed performance report that shows the predicted performance at every modulation. Please note that some of the modulations may be marked as unavailable when the link conditions are not optimal. For instance, if I select the second CPE, which in this example is located very far from the base station, you can see that the highest modulation is not available. The All Links tool, which you can open by pressing the button located near Results, allows you to view the list of links for each base station sector in your network. For each link, you have a map screenshot with the two endpoints, the path profile, and three shortcuts to the link report, sector settings, and CPE settings. As I have mentioned in the beginning, you have the possibility to export your project to a KMZ file format. To do this, expand the project settings and click Export Sites to KMZ. Then, if you open the exported file in Google Earth, you can view the elements in your network represented using pinpoints, paths, and polygons. And if I click on a sector or CPE, useful information like device model, antenna model, and antenna height will be displayed. Regarding the import of KMZ files, InfiPLANNER allows you to import only files that have been previously exported from InfiPLANNER itself, or files that have been exported from InfiPLANNER, imported into Google Earth, and then exported back without any changes. The import of raw data from Google Earth is not yet possible, but we plan to further improve this functionality in the future. Moving back to the presentation, I want to make a summary of the main benefits of using InfiPLANNER. So first of all, InfiPLANNER is a useful pre-sales and marketing tool that enables you to make quick link estimations in order to respond to customers' requests for information as soon as possible. Then InfiPLANNER provides a sophisticated environment that helps you design complex networks, both point-to-point or point-to-multipoint. You can optimize and improve the performance of your existing networks, and you can also compare the performance of different Infinet Wireless devices side by side. For example, when you are not sure whether to choose InfiLink 2x2 Lite or Pro or the XG, InfiPLANNER helps you see more clearly the advantages or disadvantages of each unit regarding the maximum throughput or the availability that you can achieve in a given situation. This brings us to the end of today's session. Thank you once again for your time, and see you again during our next webinar.